Hello guys, welcome to this lesson, and in this lesson what we are basically doing is to introduce the topic vectors. Now when we say vectors, before we can talk about vector, we need to talk about scalars. Alright, now not just scalars, scalar quantities. Okay, now what are scalar quantities? Scalar quantities are quantities that they only have magnitude, they only have size, you can only measure them, but you can't tell their directions. An example would be mass, density, temperature. So there are numerous, there are many, you can list them. Now these quantities, you can't give their direction, okay? They don't have direction, they only have a quantity. You can only measure mass as kg, temperature either degrees Celsius or Kelvin. So that's all about scalar quantities. So a scalar quantity is just a number, right? There's no direction attached to it. Then for vectors, vectors are quantities that they both have magnitude, size, and direction. For example, if I'm going to Warri, there's a direction I have to face to get to Warri, alright? Or if I'm going to Asaba, if I'm going to Abuja, there's a direction I need to follow to actually get to Abuja. Now, it takes an amount of distance before I can get to Abuja, right? So you can quantify the distance and also the direction. For such movement, that is displacement, because distance, there are two different things. Now distance is a scalar, distance here is a scalar, but displacement is a vector. Why? Because it has direction, okay? So that's the difference between distance and displacement. Both have the magnitude. That means if I want to move, I can say I want to move 20 meters northward. Immediately I say 20 meters northward, that's displacement. But when I say I want to move 20 meters, that's distance, okay? That's distance covered. Alright? So that's the difference. Now, so vector quantities, they both have magnitude and direction. Okay? Now after knowing all this, okay, so let me just list out some examples of vectors. We have velocity, we have acceleration. There's so much. Show that one again. I'll give you the opportunity to take our time to search out more of the vector quantities. Now, we have something here, unit vector. For every vector, if a vector is moving in a straight line, it just have only one component. But if it is moving in a direction that makes an angle with the horizontal like this, definitely the components will be moving along the y-axis and along the x-axis. Now we are used to this coordinates. This is basically a Cartesian coordinate. So this is the x-axis, this is the y-axis. Now if a vector, this vector p, if it's moving not directly on the x-axis or on the y-axis, if it's moving at an angle to the x-axis, it will have two components, okay? That's why you're using the unit vector. Now what this unit vector is talking about is just talking about the breaking up of the components, how we label them, okay? So for the x-axis, the unit vector moving along the x-axis is we represent it with I. Then for the y-axis, it's represented with J. So if I want to write out the total sum of P now, P is basically equals P1 I plus P2. That is the component of P as a vector moving along the y-axis. J. Okay. So now this is what will give you the total sum of P. But if I want to actually get the resultant force, we'll get to that. This is not the total formula, but if I want to get the resultant force, we'll use another method. But for this case, if I want to get the total P, it's moving along the y-axis and the x-axis. This is just a representation of it. All right. Now, when we say equal vectors, what do we mean? Now, equal vectors are vectors that are equal with size and direction. So, say for example, a vector is moving, or let me not use a vector now, let me use something relatable. Let's say I'm moving 20 meters northward. So let's say 20 meters north. Okay? And another person is moving 40 meters north. Now, both vector directions, they are the same. Okay? Alright? So they are what? Can we say they are equal? The directions are the same. Look at it. The quantities are what? Different. So there's a difference there. So automatically this becomes what? Not correct. Okay? So but if say they are moving both northward, but here is also 20 meters. Okay, 20 meters. Then we can say they are what? Correct. Then also, if we say I'm moving 20 meters north, then another person is moving 20 meters west, you can see that the quantities are the same, but the directions are different. So they are not what? Equal vector. For them to be equal, they have to be equal in magnitude and in direction. Very important. Okay. So this is the meaning of when we say equal vector. So the next one we have here now, the next one we'll be going into is the resolution of vectors. So what I'll just do now, I'll write up the diagram here. So let me wipe my board. All right. Now, if you look at the force, it is moving at an angle to the horizontal, okay? At an angle to the x-axis. Now, I can complete this triangle to make it look like this. Now, this part of it, it's RS. It's called RS. That is the component of arrow on the x-axis. And this is a vertical line. This is parallel to this line. Okay? So this is arrow what? Y. This is perpendicular. This line is perpendicular to this horizontal. So this is angle 90. Now, we can actually use sine and cosine to resolve and get RS and RY. How do we do that? It's basically using the Pythagoras theorem. Opposite, rather, the side facing the angle is what we call opposite, please. Then the side facing the angle 90 is what we call hypotenuse. Then the remaining side becomes adjacent. Alright? So I believe, I'm assuming you already know what these are from Pythagoras theorem, either SS3, SS2. Now, for sine theta is opposite over hypotenuse. This hypotenuse here, hypotenuse is arrow. That's the vector. Okay, so this will just give me opposite RY over what? Arrow. That's the hypotenuse. So if you look at this, I'm saying sine theta equals RY over arrow. So it implies that RY becomes arrow sine theta. Also, if you want to go for RX, this should give me cos theta is an adjacent over hypotenuse. Okay, adjacent over hypotenuse, so this should be Rx over R. So it implies that if I cross multiply, that's what I did, I just cross multiplied. So it will now be Rx equals R multiply R cos theta. So it means I have two components of the vector R. That's Ry equals R sine theta, Rx equals R cos theta. So what this means is that when you multiply the vector R by the cosine of the angle, it will give me the component moving along the x-axis. Then if I take the sine of this angle and multiply it with the resultant, force arrow, I will get the component moving along the vertical axis. Now, if I want to get the resultant force, if I add up everything here, to get the resultant force, all here is use a simple Pythagoras theorem that says hypotenuse squared is equal to the sum of the square of the other sides plus opposite square. Okay, so hypotenuse is R squared equals Rx squared plus opposite Ry squared. So for me to get R as the resultant force, I'll take my square to the other side. As it's crossing the equation sign, it becomes a square root of. So R squared x plus R y squared. So this is what we call the resultant force. Resultant force. Either you say R or x squared plus R y squared. Now, what is the use for this formula? Why did we derive this formula? Just in case we are given the horizontal component and the vertical component, then we are asked to look for the resultant force, or we are given that two forces are acting on a point. Let's say there's a point here at this place. There's a force acting maybe at an angle theta. Then there's another force that is acting from this way at another angle theta. Let's say this is theta 1, theta 2. So how do we get the total force acting on this body? That's when this becomes useful. Now we know that the resultant force is Rx squared plus Ry squared. Take the square root of it. Now we can expatiate further. We can, since we know that Rs is R cos, we can say this will now be the square root of, instead of Rx, you can say R cos theta all squared plus R sine theta all squared. To get the, if we want to get the, let's assume that we don't know theta. So from tan, I take a tangent of theta. It will be opposite over adjacent. That will be Ry over Rx. Now this is in a case where we are giving Rs, we are giving Ry. Now we are asked to look for the angle that the resultant force makes. Then we can use this formula to get the angle. Alright? So if you didn't understand from the beginning, now you can rewind back to, or you can slow down the video, pause the video, so you can understand everything I just did now. Okay? Then if you feel and you see that this video is giving you value, please like the video and then share the video with your friends, because the video is not just for you, it's also for your friends also, so they can learn better in a good environment. All right, so that's all from my side. I'll see you in the next video.